All right, so let's talk a little bit about database security. I got to apologize right up front for taking a little bit longer than I anticipated on getting this out, but here it is. We're going to run through some basic concepts as it relates to database security, kind of melt them in together with some of the concepts that we already talked about as far as confidentiality, integrity, availability, and so forth and so on. And then we're going to look at some basic concerns as it relates to database security. So, database security basically is the degree to which data is fully protected from tampering or unauthorized access through the entire process of the data creation, data input, data storage, and then output as well, the retrieval of information from that database. So we have to look at the whole information chain as it relates to data security, and it really comprises of both information system and information security concepts, coupled together with a couple of other strategies. So clearly, databases play an integral part of an information system. They need to be reliable and efficient programs that manage the database. Programs that manage that database become essential to the success of any information system. But although many corporations develop database management systems in which each database management system has a distinct implementation and architecture, they all basically have the same common functionalities. They allow developers and administrators to organize data in a fairly orderly fashion. They allow users to store and retrieve data efficiently. They allow users to manipulate data, update and delete. They enable developers and administrators to enforce data referral integrity or referential integrity and consistency. Data is considered to have referential integrity when the relationship between two tables is always maintained. In other words, it's never broken. Allows administrators to enforce and implement data security policies and procedures on all database levels. And we'll talk a little bit about database levels as we work through this. And it also allows administrators to back up data in case of failure and to provide for a mechanism for recovery and data restoration. Basically, the components of any database management system is the data, the hardware, software, the network infrastructure that it runs on, and then procedures, and as well as the database servers. And all of these have security concerns and controls that we have to make sure that we address. If we look at some of the common information security concepts, we recognize that information is obviously one of the organization's most valuable assets. Information security consists of a set of procedures and measures taken to protect that particular piece of information system component. And then, of course, we always look at the CIA triangle: confidentiality, integrity, and availability. And we must strive to balance these three components, especially when we're talking about database security, because one of the things that we can often do when we try to implement security is impact things like availability. And then here's a little bit of a blowout on the CIA triad as it relates to data. And if we look at confidentiality, really what we're looking at here is that the data and information that's classified into different levels of confidentiality to ensure that only authorized users have access to that information. And we're thinking about things like secret, top secret, classified, so forth and so on. And this allows us to categorize and store data that's valued at different levels. Integrity, again, data is accurate and protected from tampering or by unauthorized persons. Very important as it relates to database security, in that an individual shouldn't have access to fields or database content that they're not allowed to. And then that is informative and data and information is consistent and validated. In that if we have a database that's a database of social security numbers, it's only accepting data that is appropriate for a social security number and not allowed to put inputs into it. That's a simple example. We shouldn't see any social security number databases that are populated with letters. Availability at all times for authorized persons, authorized and authenticated persons, and then systems protected from being shut down due to external attacks and internal attacks as well. when we look at confidentiality, we're really looking at two specific aspects of security: the prevention of unauthorized access and the disclosure of information based on the classifications. And if we look at classifying company information, we would look at that doing that into two levels as well. Each level must have its own security measures. The security measures for something that's classified as secret are going to be different from those that are classified as top secret, and so forth and so on, depending upon the classification scheme that you have, and usually based on the degree of confidentiality necessary to protect the information. So in other words, the more value that we place on that particular piece of information, the more security controls that we're going to place around that, which seems fairly intuitive. And then, here's just an example of a classification scheme, unclassified being the least valuable pieces of information all the way through classified. And if you look over here on the left, we're going to have fewer controls around the unclassified, which is going to allow more access for people. And then as we move up the pyramid towards more classified or more restricted data, then we're going to have more controls, which is going to eliminate the number of individuals that can actually gain access to that piece of information. If we look at integrity as it relates to databases, we are really looking for consistent and valid data, which is processed correctly throughout the processing stream: input, verification, and output. And we can say that information as it relates to the database has its integrity if it's accurate and if it has not been tampered with. Read consistency is a term that we often see associated with integrity of databases, and each user here, to have read consistency, each user should only be able to see his changes and those committed by other users. Pretty straightforward process. We want to make sure that read consistency is implemented in a manner that is consistent with our integrity policies. When we talk about, or frequently when we talk about integrity, we also talk about the degradation of data integrity. And there's some basic concepts that we want to make sure you're familiar with as it relates to data degradation. One of them being invalid data, and I put them into a table here for you. It basically indicates that not all the entered and stored data is valid without exception. Redundant data occurs when the same data is recorded or stored in several places. And each of these lead to issues. Redundant data, by the way, can lead to data inconsistencies and data anomalies. Imagine that spreadsheet that's shared amongst a department, and everybody has the edit capabilities, but we're not actually working off of the same document. At the end of the day, perhaps we got 6 people working on the same document or working on copies of the same document. End of the day, everybody has gone in and made their changes, and now we have 6 different versions of the same document floating around. Inconsistent data occurs when redundant data, which resides in several places, is not identical. And then data anomalies as well exist, where there's redundant data caused by unnormalized data design. So just a couple of examples. Moving on to data read inconsistency, which indicates that a user does not always read the last committed data, and those changes that are made by other users are visible to others before changes are committed to. And then data non-concurrency, which means that multiple users can access and read data at the same time, but they lose read consistency. Availability, systems obviously always need to be available when we start aggregating information in databases. We want to make sure that it's available to authorized users only, and then the system should be able to determine what users can do with that information: read, write, execute, or whatever execution types of access rights that might be assigned to that particular data. Reasons that some systems might become unavailable. Again, some of the more obvious ones: external attacks and lack of system protection is generally the most frequent one. System failure with no disaster recovery strategy in place to recover when the database crashes. Overly stringent and some obscure security practices that are not conducive to good business practices, and then poor implementation of authentication processes also lead to system unavailability as it relates to databases. When we look at database security, one of the functions of the database management system is to really empower the database administrator to implement and enforce security at all levels of the database. And in order for an individual that is a database administrator to protect valuable data stored in the database, you have to know the various security access points that can make your data vulnerable. A security access point is a place where database security must be protected and applied. In other words, an area where we must implement, enforce, and audit database integrity, availability, and confidentiality. If we look at database security in this view, we want to say that there are different points of access to any database, and by far the biggest one is going to be people and individuals who have been granted privileges and permissions to access those, the applications, the networks, the workstations, the servers, the database files, so forth and so on. This means that obviously people represent a risk to database security violations, and because of that, database security must entail all the necessary measures to secure data within the database against possible violations caused by people. If we look at the application, the design and implementation, which includes things like the privileges and permissions granted to people, if these permissions are too loose or too lax, then individuals can access and violate data. If these permissions are too restrictive, they don't allow the user to perform their responsibilities. And what we look at here is when granting security privileges to applications, we have to be extremely cautious. Network access point to a database is one of the most sensitive security access points, and we have to be sure that we use best effort to protect the network and provide network access only to applications and operating systems and databases that are required. Operating systems, and we just talked about this, operating system access points are defined as authentication to the system or a gateway to the data. For example, to access data residing in a system, you have to log on and your security credentials must be verified. The absence of these good security measures at this access point is the cause of large percentage of security violations. Database management systems is the basic logical structure of the database, which includes memories, executables, and other binaries. Data files is another access point that influences database security enforcement and is access to data files where the data resides. And we really want to control this through permissions and encryption. You must protect data files belonging to the database from being accessed by unauthorized individuals. And then data in and of itself is access point that deals with the data design needed to enforce data integrity, the application implementation needed to ensure data validity, and the privileges necessary to access that data. So as you can see, each level has its own security concerns, and when I'm looking at your concerns as it relates to database security, these are the kind of the areas that I would expect that you'd be touching on a little bit. So what do we want to do? We want to reduce the access point size, reduces security risks. We want to close any security gaps that or those points at which security is missing. We want to make sure that kinks in the system and bugs in the system are addressed, are identified and addressed, because they can become threats. And then we want to make sure that security risks can become security risks in the form of threats are identified because they can become an avenue for a system breach. So we really need to focus in 4 areas, right? And then apply our security controls accordingly. If we flip that triangle over to see the other side of the coin, so to speak, it kind of shows us that when the area of the size of people access point is reduced, the only access to data is through all access points above. Reducing access points reduces security risk, in which in turn increases data security or database security. So address all of those concerns as best as we can without impacting too much of a degree of things like availability. Some different database security levels that we should be familiar with. Relational databases are a collection of related data files. A data file is a collection of relatable tables, kind of a hierarchy that we're rolling through here. A table is a collection of related rows, and rows are a collection of related fields. And each one of these have different levels of security that we might choose to implement. So in a relational database, which is really a collection of related data files, a file is a collection of relatable tables. A table is a collection of relatable rows or records, and a row is a collection of relatable fields. Think about Access, Microsoft Access, right? Same basic concept. And you should notice that the structure of the database is organized in levels, which is convenient as we need to talk about the different levels of protection that can be afforded for each, or different types of security mechanisms that can be afforded for each level. So a security vulnerability, a weakness in the information system component, and a weakness in any information system component can be exploited to violate any of confidentiality, availability, or accessibility of a system. So we want to make sure that we try to understand the different categories of database securities and be aware of some of the issues. And in this case, database security vulnerabilities, user mistakes. There could be a software issue, design and implementation of the database, and then installation and configuration as well of any application that might need to access it as well. A security threat is a security violation or an attack that can happen anytime because of a security vulnerability. We look at menace to database as it relates to security threats. We have people, whether they are intentionally or unintentionally inflict damage. Malicious software can intentionally be written to damage or violate one or more of the database environment components, applications, networks, operating systems, so forth and so on. Natural disasters are obviously a big threat to any piece of technology, but particularly so here as it relates to databases. And then, technological disasters, which are caused by some sort of malfunction in the equipment or hardware. These things can inflict damage to networks, operating systems, the databases themselves, the database management systems, the data files, and so forth and so on. So when we look at database security threats, in this case, we are looking at specific types of threats and definitions as it relates to these four categories of threats. Security risk, for example, a known security gap left intentionally open. We want to, again, kind of look at, how could these areas be impacted. And if we looked at people, for instance, if we look at the loss of an individual who are vital components of the database environment and no critical information about the environment can create a risk. So, the loss of a key database administrator, the loss of key persons or key person downtime due to sickness or personal or family problems, or so forth and so on, is a risk to database security. If we looked at hardware, obviously, things like downtime due to hardware failure or malfunction can inflict damage on a particular database, and then failure to due to unreliable or poor quality equipment. We look at data loss, corruption, data privacy loss, and then confidence as well as another area, or loss of procedural or policy documentations, database performance degradation, fraud, confusion and uncertainty about how the database actually works are all examples of database. Risks are, simply a part of doing business. As it relates to databases, the risks are inherent in the function of the particular piece of equipment or the function of the application. Managers, security managers, database managers at all levels are consistently working to assess and mitigate risks as it relates to databases to ensure the continuity of department operations. Part of this process is for the security managers and the database managers to not only understand system weaknesses and threats, but to go that extra distance to really try to diminish the probability of these threats actually occurring. So, what are the risks of security of a database environment? What are the risks to the security of a database environment? Simply put, the reliability of the database at all levels at risk, and most importantly, the integrity of the data. So if we look at security violations as it relates to or an attack can happen at any time because of a security vulnerability. And again, known security gaps left open can cause issues. What we want to do when we're looking at database security is we're really trying to identify those three key components: the software, the application, the data, and the people. And it's a blended approach that we have to take when we're talking about database security to try to mitigate those risks, threats, and vulnerabilities. And really what we're looking at is for that balance between those individuals and applications that have to access that database and really the productivity of the organization. So some security methods that might be used to protect database environments, if we look at, those levels again where we talk about people, physical limits on access, identification and authentication. We want to make sure that they're appropriately trained, establishment of security policies and procedures. If we look at the next level down, applications, we're really looking at the authentication of users who access, some business rules or policies that we have to work through. Single sign-on is a method for signing up for once for different applications and websites. Network should have firewalls to block network intruders, virtual private networks to access information remotely. Appropriate authentication, which is an ongoing and current theme throughout operating systems as well. Authentication, intrusion detection. Appropriate password policies. Database management system, again, audit mechanism, database resource limits, password policies, database files. We're looking at things like file permissions and access monitoring, and then data validation, constraints, and encryption, as well as data access are all key things. And, I really wanted to, we've mentioned this before as it relates to, database security methodology, and really what this is attempting to do is really put the pieces of the database security jigsaw puzzle together for you to really break it down into a process that helps you understand the concepts behind building database security. So what we basically are looking at on the top here is the system development lifecycle, the waterfall or tiered model, where if we're going to implement a new piece of technology or a new piece of software, it goes through some cyclical planning here. Planning, analysis, design, coding, testing, and maintenance, which is basically allows us to ensure that whatever we're building for the organization as it relates to software or application is going to be appropriate when it comes into production. On the bottom half is really the database security implementation methodology, where we're identifying, we're doing an assessment, we're doing a design, the design of the database, the implementation of the database security controls. We evaluate them, and then we audit it to make sure that it's doing exactly what we think it is. And at each phase, each time we do this auditing, they should be performed periodically to ensure that the system's security, the state of security of the system, is effective, so it's ongoing and cyclical in nature. And basically that's the kind of the implementation methodology that you should be looking at when it comes to database security. Keeping in mind that once you put that database in place, you have to go back and visit the security controls that are absolutely critical in maintaining it. So if we look at, in summary, database security, levels and degrees from being free from danger, that's what we really want to do. Database security is the degree to which data is fully protected from unauthorized tampering, and obviously information systems really play a important part in the backbone of the day-to-day operations of any organization. We look at information security architecture as it relates to databases, for protecting logical and physical assets. And when we talk about databases, that's really the concern, both the logical and the physical. And we really want to make sure that we tie it into the CIA triangle. And we need to make sure that we enforce security at all levels of the database. All right, thank you very much.